Savannah, vertical angles. There's some vertical angles in this picture. Where are they? Can you guys all grab your pointer hands and point to them? I think the girl's typing it out. Okay, there's one of them. Where's the other one? Yeah, right there. Those two that are across from each other. Very good. Very good. So I can mark that this angle and this angle are equal. You can put a little tick mark there because they're vertical. When do vertical angles happen? We've gone over this quite a few times, but this is really, really important. I really want you to be able to see vertical angles because these occur quite a bit. How do you know to identify them? What told you? I don't know who was pointing. Was it Jarrell? Pointing to these, or is it sure? You're totally right. How did you know that that would be true? Yes, then it is because the lines cross. And yep, addition to that, Natasha, because the angles are opposite from each other. Exactly, Zarel. They intersect, those lines intersect each other. Good, good, great answers, guys. Absolutely. You are all right. That's exactly what you're looking for. When you're looking for vertical angles, you're looking for any time two lines cross one another, intersect one another, and the angles are across. Um, that that is something you know. It doesn't have to be marked on the picture. You just always know, because we've gone over the vertical angles theorem. That theorem said anytime you have two lines that intersect each other, two lines that crisscross, the angles across from each other are always going to be equal. Okay. Now, the reason that that's important is for part 8. It says, can Kayla conclude that triangle ABC and triangle EDC are similar? Why or why not? So what do you guys think? We have to look at the triangle similarity postulate. So we had angle, angle, side, and side, side, side. Is there enough information on our picture for us to choose one of these? And if so, which one would it be? That's the why or why not part. Okay, so we've marked up our picture. Can we choose one of these, or do we need to like keep digging? What do you guys think? Yes, very good, guys. Yes, it is angle, angle. Yes. And so, yeah, and I appreciate that, Natasha, typing in. I'm not sure. And that is what I want to know. So when you know that you can use angle, angle is when you have two angles in one triangle that are marked the same as two angles in the other triangle. And that's what we have. We could even do like Alyssa did a second ago if we want to draw that triangle that's kind of in the downward direction. If we want to redraw that, that might help you see this a little bit easier. You don't have to, but you're just looking for two angles in one triangle that are the same as the two angles in the other triangle. And we have that. This angle and this angle are the same. This angle and this angle are the same. So that says, yes, these are similar. Why or why not? Because of the angle-angle similarity postulate. So for the why or why not, that's really what I'm looking for there, is that you know which postulate works. Okay, does that make sense? Why, when you choose, you know, how you choose angle, angle? That one's probably the most common way to identify similar triangles. Okay, let me know if that doesn't make sense. And by the way, if you guys are just coming in, what we're doing is we're reviewing the Unit 1, Part 1. Well, actually, and a little of the Part 2. This question is actually from Part 2. But what I'm wanting you to do to get credit for these is to write out your work for these. So grab a piece of paper if you don't have one. I think everyone has one unless you just came in, and just write out your work for these. Okay. Now this one, of course, you're going to write out your work because this is on the part 2. So if you have not turned in the part 2 yet, or if I have given you feedback that says, hey, come see me in small group and let's go over this one and resubmit it, then yes, you got it, Zarel. That's the why. Absolutely. That's why we know they're similar, is because of the angle-angle similarity postulate. Yeah, absolutely. Okay, so now that we know they're similar, we know number 1, the angles are equal. Number 2, the sides are proportional. So let's read the question again, or let's read part B. It says, suppose DE is 32 feet. So we can mark 32 in either place. This is just what I did here, was I just took this triangle and I redrew it so that it's going the same direction as this one, because it can make it easier to match the sides up. And what can Kayla conclude about the width of the river? So I know we didn't read the question, but this grayish area is supposed to represent the river. So the side AB would actually be the width of the river. The question saying how wide is the river, that's our X. We're looking for that side of the triangle because that's going to tell us how wide the river is. So if we know the sides are proportional now, do you guys see how we could match the sides up and create a proportion? Type that in. What are some proportions? I mean, there's different ways to write them out as long as you're being careful to match everything up. What are some proportions you're thinking? And then you guys can write that down. You can grab the whiteboard tools and write it up on the whiteboard too if you want. Yeah, or yeah, write it on your paper too. There you go, 22 over 100. That would work because that would match those up. And 32 over X. Yes, we could do 22 over 100 equals 32 over X. That would be one possible way to write that. That works. Okay. You could also do X over 100 equals 32 over 22. That might be another way if you're looking at, okay, I'm going to pair these two together because they come from the same triangle, and then just make sure that these are in the same order on the other side. Okay. All right, so those are 2 possible ways. I'll let you guys solve the rest so that you can, I do want you to show me how you cross multiply here when you turn this in. So show me all your work, show me how you cross multiply